Good morning, everybody. All right, let's get started. We're beginning a new phase in the course today. You're going to start learning about MATLAB. And so before we do that, actually, I guess I probably better take roll, make sure that we didn't lose anybody over spring break. All right, so this is class 21, and we only get to 30 in the semester. So that gives you an idea that we're getting pretty close to the end. We can feel it, right? It's going to be great. Summer's going to be great. So we're starting on MATLAB, and I'm going to give you a homework assignment after we've gone through some beginning stuff today. That'll be due a week from today. As per the usual trend, you're going to upload that to MU Online. You'll actually be doing two different files. One of the files that you create will be a Word document that has a series of images pasted into it, basically just screenshots of your work in the program. And then the other part of what you're going to submit is a script file. It's called a .m file. And so MATLAB has ways of programming, and so you're going to upload that program that you create. And so that'll be due before class next Tuesday. Any questions before we get moving into the new material? All right, if you haven't already or you haven't recently, I'd really suggest that you go into the grade book. I keep a grade book that's always current with your scores on homework, your attendance average, your exams, and there's a weighted course average at the far right of the screen that shows basically where your standing is, the weighted standing in the course at any time. And so 90 and above is A, 80 and up to 90 is a B, and so on, the normal breakpoints. And so you should be able to find out if you're missing anything that you thought you turned in and it's not recorded. If you notice any kind of discrepancy like that, please let me know. All right. So what we're starting on today is MATLAB, and MATLAB gets its name from the main application when it was first created, which was mathematics related to matrices. And so MATLAB actually stands for Matrix Laboratory. But since then it's expanded to a lot more applications, and it's a very powerful, weighty program. It includes image processing, numerical computing. Anytime there are really large data sets, there's a chance that MATLAB may be a good tool for that. And I used it when I was working on my PhD because I had millions of data points and I had to make calculations to the entire batch. And so I couldn't go in and open each file, make a small change, close the file, move on to the next one. But with MATLAB and a very short program that took just a few minutes to create, I could have it open the file, my original data file, make the change that I needed it to make, and then move on to the next file. And so I could have it set up as a batch. And so I would start the batch, come back an hour or two later, and the work was finished. And literally, what it did in just a couple of hours of opening, changing, and closing would have taken me months and months to do manually. So it's really a powerful tool, and was written a long time ago, the first version in 1977, so it's been around for a while. It's good for, as the name would imply, matrix operations. It can do mathematic calculations, and you can expand the capabilities of MATLAB beyond its sort of core functionality by add-on packages that are available. And there's a trial, for example, on the MATLAB website that if you're interested in a 30-day trial, you can download it. And then it gives you the option of different packages. Some of them are for geospatial data, some of them are for image processing. And so you can kind of target the add-ons based on the application into different fields like financial calculations and so on. But there are some types of programs and problems that MATLAB isn't the ideal solution for. There are situations where you're going to be giving your technical data to non-professionals, maybe to a client, and kind of the programming window that you'll use in MATLAB would be an awkward way for them to see the results of your calculations. And so Excel is much better at creating presentable results, like the charts and the tables that you've learned how to use earlier in the course. And in some cases, although we can do calculations on MATLAB, addition, subtraction, and so on, it's probably easier for you just to do those sorts of things with your calculator rather than coming to the computer lab, starting MATLAB, and doing your addition on the machine. It's just easier to use your own calculator that you've already got with you. So it's not the tool for every problem. Students, so I mentioned that there's the free trial that you can sign up for. They make you jump through a bunch of hoops for that free trial. Or you can buy a student version of MATLAB, which is $49. Of course, all of the computers in this room have MATLAB installed. And so when you're working on the homework, you can do it in here. Or you can connect to MU Remote. Remember, I've told you about that before. So it doesn't have to be in this computer lab. You can go to any computer that has a remote desktop connection, and if you connect to MU Remote, then it will start up a server that has MATLAB installed on it. And so you just use your normal username and password. You can see here it's got my Marshall is the domain, /wait, which is my username, and then I put in my normal password. And then it will take me to this server environment that has a lot of software installed on it. And one of the software programs that's available is MATLAB. The version that they have installed on this server is slightly different than the version that's installed here in this lab. So if I go over here to the Start window and I start typing in MATLAB, you can see that the version that they have is 2015. Whereas what's installed here in this lab, if I type MATLAB, then it's 2016. So it doesn't matter for purposes of the very simple calculations and programs you're going to be writing this semester, then you won't have to worry about the difference between MU Remote and what's in here. Now, in addition to that, if you don't want to use MU Remote, or if you don't want to come into here, there's an open source alternative to MATLAB called Octave. And you can download Octave and install that on your computer, even if you've got a Mac. This is going to be one of the very few instances in your engineering career where you'll be able to use a Mac to do engineering calculations. And so they have a Mac version of Octave, and the nice thing about that is that Octave is completely seamless in how the functions and the files interact with MATLAB. So I could do a bunch of work on MATLAB, save an M file, and then you could open it in Octave, and vice versa. So if you want, there's lots of different ways to get access to MATLAB. You can pay for it, use the trial, come into the classroom, use MU Remote, or just download Octave. And the nice thing, another nice thing about Octave is it's a much smaller installation than MATLAB. I was going to install MATLAB on my office computer yesterday, and the download was 1 gigabyte, and then once it was installed and unpacked and everything, it was going to be 4 gigabytes. And so I just got Octave instead, and I think that was maybe like 100 megabytes to install. Just because I think all of those add-ons are disabled by default in Octave. Yes?
So we can use that for homework?
Yeah. Yeah, Octave will work great for you. The windows will be a little bit different in Octave, but that's all right. Here's what Octave looks like. It has the capability of preparing plots. It has a file browser. It will give you the properties. Here's a script that it's opening, an M file, which is kind of a program, and here is the command window where you're typing in commands, and you can move around where the windows are. But it's basically the same core functionality as MATLAB. So here's the MATLAB interface, and today we're going to mostly be working here in what's called the command window. It's where you're typing in either calculations or defining variables. You can also look at your previous command history. Here on the left side is the file browser where it will give you the, if you are saving different scripts. It will tell you the location. You can identify where you want to put your data, the details of files. And then in the workspace, it tells you variables that you've defined and the values of those variables. So we'll go through all of that today. So the easiest thing that I can show you how to do with MATLAB to begin with is using it as a calculator. And that's one of the applications where I said probably you wouldn't want to even bother. You know, you could just do those calculations with your Casio. But since a lot of programming starts with math, let's do a few basic things in the command window using MATLAB. Now, a word about order of operations. Remember how picky Excel was in where you put the parentheses and the result that you get? Unfortunately, a lot of people lost points on the exam having to do with order of operations. It was a sea of red ink when it came to the order of operations stuff. And so MATLAB follows the same procedure that Excel did. And so anything inside of parentheses will be computed earlier than it otherwise would. So parentheses kind of override the rest of the order of operations. But then after those parentheses, all the work inside of parentheses has been done. It will first do an exponent, then it will do multiply, divide, and finally it will do the addition, subtraction. So just to get a feel for that, we're going to do a few calculations both on the homework and also in class today just to see how it works. And so if you haven't already, go ahead and start up MATLAB. You'll see it under the All Programs under M. So just, you don't have to activate or deactivate. Just start the program, MATLAB. Oh, I guess we do need to activate. I'm surprised that hasn't already been done. Maybe it's based on your profile. Because there's another class that uses this same classroom on Mondays. I would have thought that they would have activated. Oh, are you kidding me? Is everybody else getting the same thing? Yours is activated already? Yours is working? Okay. All right. Yours is asking for activation? Yeah, that's what this is. Let me see if I'm an administrator. So somebody saying close and then reopen. Were you getting this or are you getting the administrative thing? The administrator thing?
Yeah, for permission to make changes or whatever.
Yeah.
But it's open now.
Good. All right. Uh-huh. Okay, so we got that all sorted out. So here's what I'd like you to try. First of all, let's play around with how the parentheses affect the order of operations for the calculations. And so 7 plus 8 divided by 2, you can just type that right in and press enter. You know, the difference here between Excel is that when you're in Excel, if you wanted it to do a calculation inside of a cell, you had to give it an equal sign at the beginning to identify something as a formula or a calculation. But here you don't. So try both of those variations. So we're normally going to have 8 divided by 2 first because multiplication and division outranks addition, subtraction. So it would do 8 divided by 2 before it did anything with the plus. But you can force a change from that normal order of operations by putting the parentheses. So it'll do 7 plus 8, it'll do inside the parentheses, and then the divided by 2 takes over. Is everybody able to do the calculations inside of MATLAB? That's working fine? All right. So now let's see if you can get this one. The exponent, let's just change that. I can't say that. exponents. All right. So now how about do the exponents? They'll be first, and so it'll be 5 to the third and then divided by 2. So 5 to the third is 5 times 5 times 5, so that'd be 25 times 5, which is 125 divided by 2, 62.5. Okay, so it did the exponents before it did the division. All right, so seems to be behaving as expected so far. Now what about this one? So here we've got parentheses, exponents, and multiplication slash division. And the parentheses force this to do to the 1/3 power instead of to the 1st power. So a tiny mistake can have huge consequences. And in MATLAB, it's going to be even harder to find your mistakes than it was in Excel. Because in Excel, you always had in each cell the calculations and the numbers right there in front of you. But in MATLAB, sometimes you're going to be assigning variables that aren't immediately visible. You'll just say, for example, width equals 2. And then it will know width equals 2, but you won't be seeing it every time you reference that variable. So it can be, at first especially, a little bit more tricky to debug errors in MATLAB than it was in Excel. Any questions so far? Okay, well here's a really long one. And there may be cases where your calculation is so long that you don't want it to go any further to the right. And so you want to work on the next line. But if you press enter, it's going to immediately execute the calculation. So this ... 3 dots in a row, 3 periods, it tells the program that when you press enter, that you're continuing with, make it think it's the same line instead of immediately executing the calculation. So let's try that together. Is that probably too small to see in the back? Let me leave it large here. That's really small. Now, one of the nice things of MATLAB is if you make a mistake, if you want to redo something, you can always copy and paste. So you can highlight something and Control-C to copy it, and then you could paste it again. So let me see if I got that right. Oh, good, it worked. Do you have a question? Mm-hmm. There's not a close parentheses there. Mm-hmm. All right, so I copied it, and you can paste again, and it'll do the calculation again, or I can paste it, and you can edit things. I could make that times 8 instead. I guess since it's such a big number in the denominator, it doesn't change anything there. All right, so that is how to do a really long calculation, is to use that ... function there. Now, the output, you have some options in how you see the output. You can tell it to show lots of digits with format long, or very few number of digits with format short. So for instance, the calculation that we've just been doing, the default is format short. But if I type in format long, and then I do paste of my calculations and have it executed again, then see how long it is? So it was rounding off before. It was rounding off to 4 digits. But now it's showing all of them. So what are some of the other options besides format long and format short? You can do format short E and format long E. So try both of those. Tell it to format with short E, which is going to be scientific notations with 4 digits after the decimal point. So here I'm going to do format short E and do my calculation again. Or I can switch it to format long E and do a calculation. I switch it back to format short, do the calculation. So you can toggle between all of those. And there's also format bank, which is only 2 digits. If you're talking about finance, format bank would just do it to, assuming these were dollars, it would do it to the nearest cent. Any questions about changing the output format? I think probably the default is format short. Okay, another alternative as far as changing how it looks is loose and compact. The default is loose, where it's spacing things out to make it a little bit more readable. You see how there's all these extra spaces between where you did the calculation and where you see the answer. But if you wanted things to be more compact, let's say, on the homework, if you're doing calculations and you want to have more on the screen so that when you snip it and put it into the Word document, it's not taking up so many pages, well, we could do format compact. Is it loose and compact? Yeah, compact. And then type in the calculation there, and the answer comes more immediately with fewer spaces. So there's less excess white space when you've got format compact. But you can switch back, format loose, do the calculation, and then it's back to more of that white space and less crowded, easier to find the answer quickly after you do an operation. Okay. Now, here's some functions that are really useful. Programming and math are really closely related. And so for the homework assignment, you're going to be asked to create a program, a script, where it asks for numbers and then it does some calculations in the background and then spits out the answer to whatever formula you've defined. So these are some of the ways that the symbology it understands for how to do math. And you remember that there were certain predefined functions when we were working with Excel. For example, and a lot of them are related, in fact. In Excel there was SQRT if you wanted it to do the square root. There was sum, was in a formula that we used a lot. There was average. There was those predefined formulas. And so this is analogous to that. But there are some strange ones, though. For example, it's here in red to emphasize it. Log, when you type in log to MATLAB, it's assuming base E, which is the natural log. And so more typically, we would call that ln. But here, it's got the log function for base E, the natural log, and then you have to say log 10 if you want it to find the base 10 log. And so just to try out these functions, let's try the following problems. You want to use MATLAB to solve the following using each of these functions. And so why don't you write these functions down or maybe commit them to memory so you've got them handy so that when I go to the next slide, you have an idea of what function to use for each of these. There's one question for each of the functions. All right, so does everybody have those committed to memory or sitting next to someone with a good memory? I think the only one that's a little bit tricky, for me anyway, I had to think about it for a moment before I could use it, was nth root. Nth root. So here are the questions I'd like you to solve using MATLAB. Now you could probably do them with your actual calculator just to double check if you did it right. But try solving these in MATLAB using those pre-existing formulas, and then we'll go through and solve them together just to make sure that everybody understands and we're all on the same page for it. All right, so I'm going to try and solve these just so it's on the record in case you're watching the video later. Hopefully you already made through all of these. So the first one, the square root of 16, so you should just do SQRT 16. Now what about answer is 4? I think that works out. What if I'd forgotten the last parentheses? In Excel it's kind of forgiving. You can leave off the terminal parentheses sometimes and it'll just assume. Here it doesn't. It's still pretty forgiving, but it doesn't just complete it for you. It'll ask, well, did you mean? So if I do SQRT 16 and then just press enter without the close, I'll say, did you mean square root of 16? It corrects it for me, and then I press enter, because that's what I meant, and then it tells me the answer. So you can still be nice and sloppy, but it'll double check before it does the correction for you. All right, so the next one. 8 to the 1/3 power. That's the same as saying what's the third root of 8. So I'm going to do nth root 8 comma 3. Because if we go back to, and then enter, so it tells me 2. So 2 to the third is 8. So that means that the third root of 8 is 2. Now if we go back to the input and output here, nth root, n is the nth, and then x is the number that it's going to be applying that to. So, the mathematical expression, 8 to the 1/3 power is equal to 2. So that means that the the third root of 8 is 2. So that's nth root 8 comma 3. All right. So the next question was e to the third power. E, of course, anybody remember what e is? Like why it's important? E is used in finance, but it is 1 divided by, let's see, what was it? I think it's like the factorials. 1 plus 2 plus 3, let's see. Well, I'd have to refresh my memory. I shouldn't have asked, right? E to the third power. All right, so it is exp of 3. All right, 20.0855. And of course, I can do format long and do that same thing, exp 3, and then see more digits if I need to. And I can do format compact if I like, and do the same exp 3 and have it jammed right there. So let me switch it back, format short and format loose, exp of 3. So many options. All right, the next one was the absolute value of negative 42, which we already know is 42. So ABS negative 42, and it'll return 42. There was the natural log of 8, and that's where we have to remember, oh yeah, that was in red on that previous slide, that natural log is actually log for some reason. Okay, so natural log of 8, log of 8. So here's a critical difference between how Excel would handle it and how MATLAB would handle it. So this is the correct answer for the natural log of 8. But for the log of 10,000, I saw a lot of people got an error message when you type in log 10, 10,000. And what was that error message related to? It's the comma. It doesn't know how to handle that comma. So log 10, 10,000, and then it'll say 4. So that's the same as saying 10 to the 4th is 10,000. That's the inverse of the log base 10. Any questions so far on these? All right, so then the last one was 5 factorial. So here the formatting of it, factorial of x. So factorial of 5. And so that's 5 times 4 times 3 times 2 times 1, which is 120. All right. Great. Those are the most commonly used math functions, and there are also all of the trigonometry functions that you might expect and occasionally need to use. I'll emphasize here in red that there's difference between degrees and radians. And we had the same sort of an issue in Excel. By default, Excel works in radians. And so you have to convert an angle into degrees before you can, from degrees into radians before you can have Excel do it. And you'll remember when we did the particle tracking assignment, you know, the trajectory of a cannonball that's fired at a certain angle with a certain initial velocity. We had to convert between radians and degrees. And so here, if you just say sine of x, it assumes that the number you're putting in as x is in radians. And you have to say sine d if what you're going to be putting in is degrees. And so try that out with these 3 calculations. The sine of 3.14159 divided by 4. And that, just based on your understanding of numbers, that's obviously radians. And the second one is also radians. But then this third one is saying the sine of 45 degrees. So if I do the sine of 3.14159 divided by 4.7071, and I can do format long and see the more digits of that. By the way, I could just type in ANS and it would know the previous answer. See how it was assigning answer equals? Answer has actually become a variable, a named variable that has a number associated with it. Now every time you do a new calculation, it overwrites that previous value. So I could also do sine of pi divided by 4. What do you think pi means? Pi, obviously. So that's another pre-assigned variable that it keeps in its memory. And you'll notice it's slightly different. Why is it slightly different here? Why is this one 0.7071063 and then this is 67 and different numbers thereafter? Yeah, because this was just me typing in pi 3.14159, which is how far I've got it memorized. But then this is pi to all of its infinite number of decimals. Probably not infinite, but more than it's displaying here. Okay, what about the last one when you are doing the sine of 45 degrees? We can't use sin. This is when we have to use the SIND function. SIND 45. And so then it's the actual sine of 45 degrees that we'd expect. So I haven't written the final exam yet, but you can bet there will be some questions that are trying to throw you off in terms of log 10 versus log base E, sine D versus sine radians. It's just, it's low-hanging fruit, you know? Low-hanging fruit. All right, so be sure that you don't fall prey to those questions. Okay, so I already kind of hinted at the fact that it's not just numbers and calculations that it's doing, but it's assigning a named variable to a number. And so you can define a variable that you'd use later on, just like how you could name a cell in Excel. You know, if you had the width of something in cell D5, you could just name cell D5. You could call that width. And so anytime you're typing in a formula, you could use the word width instead of having to remember the location of where that number was. And so the same thing is true here, the same kind of usefulness. You don't want to remember what exactly was the width number, but you just want some number to be assigned to the variable width. And so try that out. Try assigning a variable width equals 2.3, and then when you do that, it should end up in the command window like it's like you can see. Now, I'll point out it's case sensitive. So here we've got a capital W. If you try and call on that variable with a lowercase w, then it won't be able to respond. So here, once I define the width, W-I-D-T-H equals 2.3. All right, so over here in the workspace, I can see the variable as one of my defined variables, and I can say, no, wait, remind me what was width? So I can type in W-I-D-T-H, and it'll respond with the number. But if I type in lowercase w, then it says it's undefined. Okay? Now, it echoes whenever you define a variable, just to confirm that it understood what you typed in. It's actually not for the computer to confirm it, it's for you to confirm it, because we humans are so notorious about typing the wrong thing. But you can disable that echoing by using the semicolon. So if you don't want it to echo to you, if you're trying to save some space, and I already showed you the workspace where it's defined the variable. So let's try that. With a lowercase w, width equals 1.5, and now I'm going to put in that semicolon, and if the semicolon's working correctly, then it shouldn't echo. So it didn't. It didn't echo, but you can see it shows up as a variable here in my workspace. So it differentiates between capital width and lowercase w width. Any questions about that? Now that's not a permanent thing, that semicolon. It's not like now it's never going to echo. It only applies each time you use it. So it's like kind of a one-time use command. Now there are some rules on variable naming besides the case sensitivity. Maybe the case sensitivity is the most important one, which is why it's in red here. The variables can have alphabetic characters, they can have numeric, they can have underscore, but they have to start with an alphabetic character. They can't start with a number. And they also should be less than 63 characters long, or else, if it's longer than that, then it will truncate your variable to the first 63 letters that you type in. So you can have some really long variable names. Like you could say, this is an extremely long variable name. I had a great spring break equals 7. And it'll keep that. But if I try and use that longer, like if I repeat it twice and I wanted that to be equal to 8, then it'll say, well, that's a little too long, so we've truncated it to the first 63 characters. So that gives you a lot. You can define a lot of variables. If it can be 63 characters, they can be uppercase, lowercase, numbers, and underscore. There's a lot of permutations that's available to you there. So here are some acceptable versus unacceptable names. You know, this first one, first speed, wouldn't work because it's beginning with a number. Can't do that. You can't use the second one, warning speed kills, because it has characters that aren't allowed. In that colon and the exclamation, those special characters aren't allowed in MATLAB. The same thing is true with the one down here. Even though underscore is allowed, the exclamation point isn't. All right. Okay, so we already defined a width. Now let's define height. So assign that. Height equals 4.1. It looks like we want to suppress the echo, thus the semicolon. Okay, so height equals 4.1, semicolon, to suppress the echo. Here it is over in my list of variables, including these important ones. All right. So once we've got a width and a height, the obvious next step is to calculate the area. Now, it's going to do something interesting when we say area equals width times height. It's going to do the calculation, and it's also going to define the new variable for us. So it's a 2-for-1. So area equals width times height. So it performs the calculation, and it also calculates the area. I'm going to format short and see the area. 43.0, a 9.43. Okay. So since we suppressed the echo, then it didn't respond with the height. I'm not sure what it would do if you suppress the echo after defining area. I wonder if it would just create a new variable. So, you know, I've got this lowercase width. I'm going to do something called lowercase area equals width times height and suppress it. So I think it won't do anything except for create the new variable with the answer that's assigned to it. Yeah, so we don't get to see the answer, but we've got the answer over here with lowercase area as the value. Okay? Now, one of the things that's tricky is that MATLAB doesn't always work from left to right. You know, since we speak English, sometimes that's how we think. We think from left to right. But MATLAB doesn't necessarily speak English, it speaks math. And it can be programmed to consider expressions from the right towards the left or from the left towards the right. And specifically what I mean by that is, you know, there's two sides to every equation. And what we just did in computing the area was, first of all, there was two things that happened there. First, we had the calculation of width times height. It did that first, and then it created the variable. So the reason why I specifically mention that is because you can reuse variable names over and over again and overwrite the previous value. So for instance, consider this formula. Area equals area plus 3. So the way that MATLAB would interpret this statement is it's going to do what's on the right side of the equation first. It's going to take whatever it already knew is the area. It's going to add 3 to that, and then the result it's going to name to the newly updated variable of area. So if we go into MATLAB and look over here in the workspace, right now it says area is 9.43, right? That's what it has stored in its memory. But if I say area equals area plus 3, it's going to take the first version of area, which it has in its memory now, add 3 to that, and then the result it's going to overwrite, and so that my variable over here has a new value. It's going to go from 9.43, now it's saying 12.43. And so I could do that again. Area equals area plus 3. And it just keeps growing. So we're overwriting the existing variable. So that's another one of the key points that you need to take away from today, is that in a formula like this, it's doing the right side of the equation before it does the left side of the equation. And the left side of the equation is assigning a variable name. So as it was put on this slide, you know, variable equals expression. It does the expression, then it assigns it to a variable. Any questions about that? Did everybody try it? It's awfully exciting to watch that variable increase. It's because you're in command. That's what programming does, is it makes you the master of the universe. All right? So there's some other things is, you know, we don't have to use the equal sign like we did in Excel. And that ants variable, ANS, is always being overwritten if you do type in just the numbers themselves. So here, we'd already calculated width, so we can do width squared. So we can call on variables and have it do the math on the variable, but now it's calling this answer. And so we could call it width squared equals width to the power of 2, and it will create a new variable, but we don't have to do that if we just want to see the result. So ants is when I had previously done the calculation, so it's always overwriting this ants. This is starting to get pretty jammed up over here, lots of variables. You can readjust the window sizing if you need to. So ants isn't a variable that you can use. You can't define it yourself. There's certain names that are kind of like reserved names. Here are some of the reserved names that are predefined already, like it's keeping them and you shouldn't use them. We already tried out ants. Now what about clock? Clock is an interesting one. Try typing that in and see if you can make any sense of what it does for clock. Okay, so here, clock. What does that even mean? How is that the time? Well, first one is the year, 2017. The next field is the month, 3. The next field is the date, then the hour, which is 11:59. Wow, time flies when you're playing with MATLAB, right? 11:59. So that's clock. Yeah, the last one's seconds. So we can, if you ever want to know what time it is, get up out of your dorm room, come in here to the computer lab, log on, assuming that you don't have an activation error. You just type the clock function, and boom, you know what time it is. It's easy, right? Or you can just listen to the chimes or look at your watch or anything. Okay, there's also other functions that are interesting to try. Date. So let's date. And it'll say no thank you. No, it'll tell you March 28th, 2017. Pi, we've already used pi. And then a few of these less interesting ones, like EPS is just the smallest number that it will recognize. I don't know why it would be 2.2 times 10 to the minus 16th, but there it is, EPS, the smallest number that it can handle in its memory banks. Infinity, and so on. So these are reserved, pre-existing variables that are always there, even if they're not shown over here. So, and you can do calculations with them. You can do, like, for example, I assume, time times 2. No, can't do that. You can do, what was time? Clock. Let's try clock times 2. Yeah. So that works. That's interesting. Date minus 1. So many options. All right. All right. So there are some other keywords that can't be used as variable names. So break, case, catch. This is similar to like the list of words you can't say on TV. You know, George Carlin's famous routine. Yeah. So he has the list of words you can't say on TV. These are the list of words that cannot be used as variables because they are programming language that MATLAB uses in scripts. So you can't, unfortunately, assign if you really wanted to. I mean, you can do break 2, and then that could be a variable, or break underscore, and then you just change it a little bit. And then I already got a good question today, like when the window gets so jammed up, you know, like this is all messy, how do we clean this up if we want it to all go away? So CLC means clear command window, I assume, and now it's empty. All of my work is gone, and so I have to type it all in again. So don't do CLC before you take your screenshots. And then see all of these variables over here. If you wanted to clean that up and purge its memory, then you could do clear. And now that I've typed clear, the workspace is devoid of any variables. It doesn't even have anything for answer, but it still knows clock. Thank goodness. Yeah, that one's not shown, but it still knows the clock. Okay. Oh, I should have had you do who before I had you do clear, because who will list all of the variables, similar to what you can already see in the workspace. And so if I had width equals 2.3 and height equals 1.8 and depth equals 8, and then I say who, then it'll tell me my variables. If I have who s, then it'll tell you a little bit more information about the size of the matrix, how many bytes it's storing, and so on. Oops. All right, so let's say that you're working on MATLAB and you need help. You can get help that's specific to a certain function. So you could just try typing in help sign, and it will echo some information on how to use it, what it's for. And then there are links there to bring up MATLAB's help package. More information. All right? You can get more generalized help up here. There's a search bar inside the program. And if you start typing it in, then it'll automatically fill in. So here where I sign, it'll start guessing at what you mean. And that's similar to in Excel when you started typing in a function, then it would tell you a little bit about the formatting and so on. So here you can bring up the information about any of the functions that you want to learn more about. You click on it. I'll tell you the syntax for it, give you an example so that you can be sure that you're using it correctly. Okay, so that's a good way to find help. In addition, there's a website that MathWorks, which is the company that sells MATLAB, keeps current, some help documentation. So it's a whole library full of the capabilities and the answers to frequent questions that people have about how to use MATLAB. All right, so with that, I'm going to give you the assignment. And if you'd like to stick around and work on the first page of the assignment, you can definitely do that. It's some calculations. The back page of the assignment is related to writing scripts and programming. And we'll do that on Thursday. So you won't be able to, unless you already know how to use Excel from previous exposure, you probably won't be able to get started on the second half of the assignment quite yet. But if you would like to leave, then you're welcome to. And if you came in after I was calling the names and you need me to adjust the grade book with your attendance, then please let me know before you depart. There you go.